Hello everyone, this is Mr. Underkoffler, and today we're looking at the guided notes called Mixed Problem Solving with Proportional Relationships. Alright, problem number 1, multiple answers. Circle each one that is correct. So this is not traditional multiple choice. This is the kind where more than one of these answers could actually be correct. For cooking jasmine rice, you should use 3 parts water for every 2 parts rice. Which choices below are proportional to the ratio above for cooking jasmine rice? Well, probably the first thing we should do is take the ratio we were given, 3 parts water, 2 parts rice, and let's divide that so that way we can find out what that unit rate is. And if we go ahead and do that, 3 divided by 2 is 1.5 or 1.5 parts water for every part rice, or per part rice. Now, the reason I did that is because I want to then take every ratio I was given here, choice A, choice B, choice C, choice D, divide each of them and see which ones are the same, because the ones that are the same will be proportional. Go ahead and underline that word. Proportional means equal ratios. So let's get ready to do our work. Although having said that, do I really have to do work for choice A? 1.5 cups water, 1.5 parts water, and 1 cup rice per part rice, which means 1 part rice. Notice these answer choices will actually give a real unit of measure, even though the original ratio just said the generic word parts. Some ratios will do that, but then when you get to the answer choices, they actually give you actual units of measure. Okay, so here's the point I was trying to make. Choice A is the exact same unit rate that I already had. 1.5 water for every 1 part rice. That's what this says, 1.5 cups water for 1 cup rice. So choice A will work, but there might be more choices to work. How about choice B? 4 cups water divided by 3 cups rice. What does that give me? Calculator time. Oh, 1.3 repeating cups water per cup rice. That is not the same as 1.5. So goodbye choice B. What about 4 cups water for 2 2/3 cup rice? We'll have to use our fraction mixed number key here for the 2 2/3. Take 4 divided by 2 2/3. And oh, look at this. You should have got, I bet you probably got 1.5 in your calculator. Well, you should know that's the same as 1.5. So there you go. Choice C is also in this ratio of 1.5 parts water per every part rice. What about choice D? Take 7.5 divided by 5. You know what? You should really do this on your own. If you haven't hit pause, done it on your own, you should now. What do we get? Well, we also get 1.5 cups water for every cup rice. So choice D is also correct. So this was an interesting problem. 3 of the 4 choices were actually proportional because they had the equal ratio to the one we were given in the original recipe. Okay, problem number 2. Again, multiple answers. So that means there's probably going to be more than one that are going to be correct. A barbecue sauce recipe uses 2 parts water, 3 parts brown sugar, and 6 parts ketchup. Whoa! We got a 3-part ratio, which means setting up one fraction and dividing is not going to work. Okay, let's keep reading. Which of the following sets of ingredients are proportional with the recipe? And you can see what these choices are. Okay, there are several ways of doing the work to figure out this problem. One of the easiest ways is to set up ratios and divide using the numbers from the original recipe and then their corresponding numbers from the answer choice. You're like, Underkoffler, what do you mean? Okay, well, the recipe said 2 parts water, 3 parts brown sugar, 6 parts ketchup. What we can do is we can take those numbers right here. 2 parts water, 3 parts brown sugar, 6 parts ketchup. Make that our denominators, and then our numerators can be from the actual answer choice. 1/2 cup water, so 1/2 cup water for 2 parts water, so water's with water. Brown sugar's with brown sugar, 3/4, there we go, over the 3 from the original recipe, okay. And then the 1.5 ketchup, is over the 6 parts ketchup. So from choice A, we got water, brown sugar, ketchup. From the recipe, water, brown sugar, ketchup. We will divide these. Now, I know I already have this typed up for you in your calculator. 1/2 divided by 2. Sorry, did I say typed up for you in your calculator? I meant to say typed up for you in your guided notes. 1/2 divided by 2 is 1/4. 3/4 divided by 3 is also 1/4. 1.5 divided by 6 is, hey, 1/4. So what does this mean? This means choice A from our original set of choices is proportional because every time we divided, we got the exact same ratio. We got it from the water, from the brown sugar, and from the ketchup. It was the same ratio. Here it is again. Choice B this time. Now remember, the original recipe from the original word problem said 2 parts water, 3 parts brown sugar, and 6 parts ketchup. Now we got 3 cups water, so we got our water ratio 3/2. 4.5 cups brown sugar, so 4.5/3. 8 cups ketchup, so 8/6. Divide 1.5, 1.5, which is the same as 1.5. These things are interchangeable. They mean the same thing. But wait, 1.3 repeating, that's not the same. So what does this mean? Choice B, no good. We're crossing it out. Okay, now that I showed you how to do this for answer choice A, answer choice B, I would like for you to try it on choice C and you to also try it on choice D. This is at the bottom of the first page, on the bottom left, bottom right. So hit pause on the video, do choice C's work and choice D's work on your own, then hit play when you're ready to see how you did. Okay, I hope you already done choice C, choice D. If not, you got to hit pause now. Okay, so we got the 1 cup water, and that was from 2 parts water from the original recipe. 1/4 brown sugar. The original recipe said 3 parts brown sugar. We got 3 cups ketchup. The original recipe said 6 parts ketchup. So here are our fractions. 1 divided by 2, 1/4 divided by 3, and 3 divided by 6. Will this give me the same thing every time? Well, 1/2 is obviously 1/2 or 0.5. 1/4 divided by 3 is 5/12. I don't think that's the same as 0.5. If you don't know for sure, take 5 divided by 12. Yeah, you got like 0.416 repeating. Not the same. Now, 3/6 is the same as 1/2 or 0.5. But this one in the middle, no good. So what does that mean? That means, and here's my proof. There's that 0.416 repeating I was talking about. So choice C is no good. It is not proportional. We did not get the same ratio every single time. What about choice D? Did you have 1/1/3/2? Did you have 2/3? Did you have 4/6? Did you divide 2/3? This one already was 2/3, which is 0.6 repeating. Now, again, same thing as 2/3. And 4/6 is also 0.6 repeating. Again, same thing as 2/3. If you don't believe me, take 2 divided by 3 in your calculator. Well, we already did. It was right here. Got 0.6 repeating. So all 3 of these ratios are the same. And so let's go ahead and circle choice D. This one is proportional to the original recipe. All right, let's go ahead and flip the page. Problem number 3. Multiple answers. Circle each one that is correct. The ratio 1 part cement, 2 parts lime, and 3 parts sand can be used to make a common type of mortar used indoors. Which of the following choices are proportional to the mortar ratio? Okay, very similar to problem number 2. We got a 3-part ratio, and they're giving us multiple possible answers. Circle each one that is correct. I want you to do all the work on your own, and then hit play to see how you did. So hit pause now, do number 3 completely on your own, then hit play when you're ready to see how you did. Okay, did you already do number 3? If not, better hit pause now. So I'm going to take the original recipe and I'm going to make that my denominator. 1, 2, 8. Boom. We got 2, 4, 12. So that's my numerators. Let's divide. And no. The last one, 1.5, not the same as 2. So goodbye, choice A. Let's do the work for choice B. Now remember, my denominators come from the original recipe of 1, 2, and 8. So there's my 1, 2, and 8. Now I'm going to take 4.5, 8, and 36, and I'm going to divide. And let's see, 4.5, 4. Oh, 4, not the same. 4 is not the same as 4.5. So choice B also is not proportional. What about choice C? Again, my denominators are 1, 2, and 8. My numerators are 5 3/4, 11.5, and 46. Let's divide. 5.75 or 5 3/4, 5 3/4 again, and 5.75. 0.75 is the same as 3/4. Same thing. So all three of these are the same. Choice C works. What about choice D? Again, my denominators are 1, 2, and 8. Now we got 15, 30, and 120. 15 over 1 is obviously 15. 30 divided by 2 is also 15. 120 divided by 8, you probably used a calculator for that. And hey, it gives you 15. So all of these gave us the same ratio. So this one is also proportional to the original recipe for our mortar ratio. All right, let's switch it up a little bit. Questions you should always ask yourself whenever you're solving math problems. Now, these are basic things, but they're so important you don't want to skip these things. Starting with, whenever you've read a problem, asking yourself, okay, what am I given? What am I asked to find? And when you realize what you're given and what you're asked to find, then that's going to lead you to, what can I use that I've already learned that I can use to solve to get from what I'm given to what I'm asked to find? And then after I've done that, we should make sure our answer actually makes sense. All right, so problem number 4. After 8 hours of work, Tyler earned $109.60. If he earns the same amount per hour, how much more will he earn from 11 hours of work than in 8 hours of work? Okay, so what were we given? We were given the fact that 8 hours is making $109.60. What were we asked to find? How much more he's going to earn from 11 hours than 8 hours. Well, from knowing what we are given here, we can start figuring out what we need to find and what we can use to get to that end point of what we need to find. So how much more will I have from 11 than from 8 hours? Well, that's a subtraction problem. So at the end of my work, I'm going to go ahead and underline that at the end of my work. After I have the amount of money for 11 hours, I can then subtract by the amount of money from 8 hours. Okay, cool. So we need to find out Tyler's, but how are we going to find 11 hours, the payment for 11 hours? Well, if I take the 8 hours and $109.60, I can divide and get the unit rate, the pay rate. In other words, how much he would make for 1 hour. And then I can multiply that by 11 to get what he would make for 11 hours of work. So that's one way of solving this. Let's go ahead and start doing this together. So $109.60 for 8 hours. Write that down. And we are going to divide this just like we normally did for getting unit rates or pay rates or unit price. It's all the same kind of idea. We divide. And we're going to get $13.70. Now, I know you just got 13.7 in your calculator. I know. But dollars and cents, 2 digits after the decimal point. That does matter. Per hour. Now, per hour means times the hours. And that will equal what he is going to earn or what he's going to be paid. So I could call that P or E. What I'm going to do with that is I'm going to multiply that times the new amount of 11 hours. Now, do I truly have to set up this as an algebraic equation? No. Maybe instead of doing this and even this here, maybe I just do this. Maybe after I get $13.70 per hour, I take that times the 11 hours. If you want to do that, fine. But on your notes, I just wanted you to see how this ties in to writing algebraic equations that we had learned a few units, or not a few units, a few guided notes packets back. So calculator time. What is 1370 times $11? Let's do it. Boom. $150.70. Are we done? No. What were we asked to find? How much more he will earn from $11 or 11 hours of work than 8 hours of work. So I now know the 11 hours number. I already knew the 8 hours amount of money. What I'm going to do is I'm going to subtract those numbers together so that way I can get how much more he will earn. Boom. $41.10 more. Again, you could have used a calculator for that. That is the answer to the question. Now, there is sometimes more than one way to solve. Remember how I said, what can I use to solve? Getting a unit rate and then writing an equation from that, like per hour means times hours, is not the only way we've learned to solve word problems. We also learned something called a proportion, where you would say 109 over, or $109.60 over 8 hours is equal to unknown dollars for 11 hours. This is a proportion. We just learned this not that long ago in a very recent packet of guided notes. And then you could cross multiply. Take, let me go ahead and use my pen here. Take 11 times 109.60, you get 1,205.6. Take 8 times x, 8x. Then, boom, divide by 8. And look, you get the same number we already had from the other way of doing it. So there's more than one way of doing this. And then obviously you would subtract. Now, do you need to write all this down? No. If I were you, I'd probably write down the proportion just so you have it on your page of notes as an alternate way of solving part of this problem. It wasn't giving you the final answer, but it gave you the amount of money for 11 hours. I don't care which way you do these problems. Your choice. With that being said, problem number 5. You're going to hit pause. You're going to do this on your own. And you can use whatever method you want. Just make sure at the end that you have actually answered the question and that your answer makes sense. So hit pause now. Try number 5. Do all the work on your own. Then hit play when you're ready to see how you did. Okay, did you already do number 5 on your own? If not, you got to do it on your own. You got to hit pause. Here we go. I'm assuming you already did it. For those of you who did it the unit rate method, you would take 32 passes divided by 40 attempts, and you would get 0.8 passes per attempt that are being completed here. In fact, I should have put completed here instead of just passes. That was kind of a poor choice here. I should have put completions. Anyway, this is actually the same as 80%. We'll talk about percent in our next unit. From here, per attempt means times the attempt. So with that in mind, I can take 0.8 times the new amount of attempts, which is 70 attempts. And that's going to give me the answer of 56 completions. Now, I need to know how many more passes he will complete from the 70 attempts than from the 40 attempts. So I already know he completed 32 passes from 40 attempts. Now I got 56 completions from 70 attempts. So let's take the completions of 56 and subtract the completions of 32. And boom, there you go. 24 more passes are completed from the 70 attempts. I should have said more completions instead of just more passes completed. Now, could I have done the proportion method? Yes, I could have said 32 over 40 equals unknown out of 70. Cross multiplied and solved, got 56 passes completed, and then again subtracted at the end to get my final answer. So I don't care which way you did it, both methods work. If you want to find a unit rate and then multiply that times the new attempts, fine. If you want to do a proportion, cross multiply and solve, fine. But at the end, you got to take the passes completed and subtracted by the original passes completed to find out how many more passes he will complete. Okay, the last 3 problems on this packet of guided notes are a variety of problem-solving problems. I'm not going to give you any lead-ups to them. I'm not going to do what I did on number 5, where I did number 4 for you, and number 5 was just like it, or how number 3 was just like number 2, and it was kind of a build-up from number 1. This time, I'm leaving this all for you. You guys have learned what you need to learn about unit rates, equations, even graphs, and how they tie into proportional relationships. You've learned all that stuff on your own. I want you to take what you've learned and apply the basics of problem solving that I mentioned on the previous page. What am I given? What am I asked to find? What can I use to solve? And always go back to, did I actually answer the question? Did I actually figure out what they wanted me to figure out? Does my answer make sense? Those are things that you need to be asking yourself in your head and double checking in order to solve problems. So try 6, try 7, try 8 on your own. And when you're done, you'll hit play to see how you did. Okay, did you already do number 6 on your own? If not, you got to hit pause now. Okay, let's break down number 6. We know each of them are going to drive 180 miles. That's what we're given. We're also given that Kelly's car averages 36 miles per gallon, and she's charged $3.45 per gallon. Tracy, we are given in the paragraph that she is charged $3.15 per gallon. But we are never told how many miles per gallon her car is going to get. At least not in the paragraph we're not told. So here's what I suggest you do. Let's take Tracy's, Kelly's, let's separate our work into 2 sections. From the graph, we know since Tracy is going to go, they're each going to go 180 miles. I don't really need to know Tracy's average miles per gallon. If I want to, I can find it. I can take 120 divided by 4 or 60 divided by 2. It's going to give me 30, but I don't really need that. I can already go to this graph, and right here, boom, 6 for 180 miles. That's what each of them need to drive right there. So I know that Tracy needs 6 gallons of gas for 180 miles. And I know that she is going to be charged $3.15 per gallon. $3.15 per gallon. Per gallon means times to the gallons. Take 6 and multiply that times the $3.15, and you will get $18.90. Now, did you have to write an equation? No. But should you have taken $3.15 times 6? Yes, you should have. Now, what about Kelly? 36 miles per gallon. I need to know how many gallons is she going to need to get to 180 miles. So here's that very simple work. Take 180, divide it by 36, and you will get 5 gallons of gas that Kelly is going to need. Now, she's charged $3.45 per gallon. Let's go ahead and multiply $3.45 times 5. Did I just put a typo here? Yes, I did. That should be $3.45. Come on, Mr. Underkoffler. All right. Multiply that times 5, and boom, $17.25 is what Kelly is going to be charged. Now, what did the question want to know? The question said, who is going to pay less? And how much less will they pay than the other person? Well, the person who's going to pay less is Kelly. And we are going to have to subtract to find out how much less. Boom, $18.90 subtracted by $17.25 means Kelly is paying $1.65 less than Tracy. So there you go. I made sure I answered the question. It was a 2-part question. I made sure that I answered that Kelly pays less and she's going to pay $1.65 less than Tracy. Okay, problem number 7. At a local grocery store, you can make your own salad at the salad bar. The salad is priced at $8.49 per pound. how much will 10 ounces cost? And I gave a little hint. 1 pound is equal to 16 ounces. Now, I apologize. I think the copies that I made in 2024 accidentally say 10 ounces. So if you are one of my students in 2024, I apologize. You're going to have to change this to 16 ounces instead of 10. My apologies for that. There's a couple ways you can do your work. Some kids will try to set up a proportion. 8.49 per pound means for 1 pound. And what would it be for 10 ounces? The only problem is pounds are not the same as ounces, but no problem. I can take the fact that 1 pound equals 16 ounces, and I can replace 1 pound, boom, cross it out, or just erase it, replace it with 16 ounces. Cross multiply, divide, and I get, well, my calculator gives me 5.3065. That is $5.31. Okay, there's another way of doing this. I can just take 8.49 and divide by 16 ounces, because per pound is the same as for 16 ounces. That will give me the price per ounce. And then I can go ahead and multiply that by 10 for 10 ounces. Now notice, I did not round this price per ounce. Taking a rounded answer and then using that to get more answers can lead to wrong results. So don't round that, because you're going to take it times 10. Then when you get a final answer, then you'll round it to the nearest cent. And finally, there's one more way of doing this. You can take the fact that we had 10 ounces, but a full pound is 16 ounces. You can take 10 divided by 16. I bet most of you didn't do it this way, but you could. 0.65 pounds, then multiplied to the original unit price of $8.49 per pound. And that would give you the same answer. Now, again, do I expect you to do all three ways? No, you picked whichever method you wanted to do, and that was totally fine. Finally, problem number 8, last problem-solving problem. The company where Jen works is keeping track of printing cost. A ream, which is 500 sheets of paper, costs $7.39. But about $9 of ink is used for every 200 sheets of paper at the printer. If Jen is printing out a report that uses 3 sheets of paper, hint, it's also going to use ink for 3 sheets worth, how much will that report cost? Okay, so we got 2 different things going on. We got the ink and the paper and the ink. There's a couple ways of doing this. You can do unit rates or you can do proportions. I have both ways prepared to show you. For those of you who did unit rates, get ready to check your work. For those of you who did proportions, skip past this part of the video and get to the part where I do the proportions method. All right, for unit rates, let's start with the paper cost. Divide, you will get this ugly answer. Do not round it. For the ink, divide, $9 divided by 200 sheets. Notice the money always goes on top. We talked about that earlier in this unit. That's going to give you this number. Do not round it. From here, add them together, multiply by 3. Why? Because I need for 3 sheets of paper for the whole report. That's going to give me 0.05978 times 3. Now I finally round. Notice I did not round until the very end. That's very important. For those of you who did proportions, 739 over 500 equals x over 3 because it's 3 sheets of paper. And for the ink, $9 over 200 sheets equals x over 3. Cross multiply. Boom. Divide by 500 for this side, and that's going to give you this. Do not round that. Over here, cross multiply, divide. You get this. Do not round. Add them together. Now, you don't have to multiply by 3 because we already used over 3 in our proportion, so that's already been covered. Boom. Now you round to the nearest cent, and you get about 18 cents. It was actually 0.17938, but we round up because the 9 in the thousandths is big enough to make the 7 in the hundredths round up. And that gives you 18 cents for the 3 sheets report. All right. Thank you for watching this fairly long video. We'll see you next time.